Hello, my name is Steven. Welcome to Highfinder Tech Talks. Today we have a topic called CVM. And when I was a project manager many years ago, we had a huge fight whether we need CVM or what we're going to do without CVM. So I'm particularly happy that we'll be talking about that today. It stands for cell voltage monitoring. And we have an expert to talk about this today. It's a guy who basically has been in electrochemistry since high school. He has a doctorate degree in that and now works for Smart Test Solutions. So I'm very pleased to welcome Markus Schuster. Hello, Markus.
Hello, Steven. Great to be here today.
Perfect. Thank you. So I see you didn't come alone. You brought some components with you. What do you have here?
So first of all, I brought some cell voltage monitoring devices with me that you can look on it. So on the one side, a modular device for research and development. We have a single board solution that's mainly for serious applications. And we have the second component that is important in that context as well, cell voltage pickup.
Cell voltage pickup. Okay, good.
Because here is monitoring.
Yes.
Here is getting the voltages out of the bipolar plates.
Okay, so we have cell voltage monitoring and cell voltage pickup. Okay, so let's take it one by one. What is cell voltage monitoring?
So a CVM system is first of all a monitoring device that measures individual cell voltages or cell group voltages within a bipolar electrochemical stack. That can be a fuel cell or an electrolyzer.
Okay, I see you have this mock-up here, if I may take that, which essentially this is sort of like a set of cells that you have here. And when you say cell voltage monitoring, where would you be monitoring here? From where to where?
So the monitoring is done within the electronic component.
Within the electronic, okay.
Yeah, but you have to get the voltages out of the stack.
So measurement, or what you would call that? Yeah.
We call it cell voltage pickup.
Pickup. That is okay. All right.
Exactly. And here you see a mock-up of an electrochemical stack.
Yes.
It's a fuel cell. You see here the cell voltage pickup component that is here.
Yes.
So in reality it looks like this.
Yes.
And you have here the pinholes. And this pinholes is the interface that we use for getting the voltages out. So we stick this cell voltage pickup component inside the pinholes.
So that goes in there, okay.
And every contact has a directly electrical connection to the bipolar plate.
Okay.
And we measure the potential of every bipolar plate.
Yes.
And our cell voltage monitoring devices get the data and calculate the differential voltages between two neighbored pinholes.
Okay.
And that is the cell voltage.
Okay, so that means we have a cell, and at the bordering every cell is the bipolar plate, and that's exactly where you pick up that voltage and essentially measure that between two. Okay, now I've used the word measurement. Is so cell voltage measurement the same thing as cell voltage monitoring?
Correct.
It is. Okay.
So the CVM is a sensor. It has no influence on ECU control tasks. We are just a sensor providing data.
Okay. So we've seen this is so we'll talk about pickup in a minute, but just take us a little bit deeper with the monitoring part. So say we have now the electric potential, you call it, or what, between the two cells. How does the monitoring part work? How does that go?
The monitoring part collects all data.
Yeah.
Normally fully parallel, because for our customer it's very interesting to see hundreds of voltages.
Yes.
Fully parallel in real time.
Yeah.
That's an important topic, and the data summary is done within the CVM system. Yes.
Okay. So when you say your customers wants to see this, so who wants to see the result of this? Where is that typical applications for cell voltage monitoring?
First of all, wherever you need a bipolar electrochemical stack.
Okay.
Fuel cell, electrolyzers, batteries.
Yes.
A CVM can be needed. Sometimes is required. And therefore our markets are widespread. So we have automotive customers, we have customers in the aviation field, in the train field, in the truck field, in the ship field, so everywhere. But as well in the industry for electrolyzers, that's a growing business at the moment because it makes no sense having fuel cell driven cars.
Yeah.
But no way to get the hydrogen.
Okay, so that's why you need electrolyzers to make the hydrogen.
Yeah.
Yeah. Okay. So I think let's go into this more and more, because I think you've already said whether you need it or not. I would like to understand a little bit more. So, cell voltage monitoring again. We said pick up the voltage, and then what happens? You know, what are the components that actually lead to us having a measurement result?
So here I have a slide where we can have a short look. So
yeah.
First of all, you have the cell voltage monitoring device. It's the board. It's the same.
So that's this. That's okay.
Exactly.
And this has on it. I see several ICs and okay. Yeah. Okay.
Yeah. This is a board with 170 channels. So here you can measure 170 cell voltages.
Okay. So 170 cell stack could be connected to this, or battery cells. Okay. Yeah. Okay.
Exactly. So. This is the core component within the system. Then you have here the cell voltage pickup unit. So here's a reality part of this.
So this connects to the actual cell, and this transmits the current, and then this one. Does this stick right on here?
This is the connection to the to the cell voltage monitoring board, and it's just
okay. There you go.
And you have the connection and the data.
So if I had a stack, I just attach this on the stack, and then okay. So this can be near the stack. Okay. Does it matter how far, how long this distance is, or can be?
It can be 5 centimeters. It can be 5 meters.
Really? Okay.
No.
Okay.
No matter here. So, but when you just have these components, you need to fix them.
Yeah.
Close to the stack. Then that's the mechanical framework that we need as well to mount the components on the stack or at the side of the stack. And last but not least, we have a harness.
Yes.
For power supply of the electronic device and for getting the data out.
Okay, so this will what kind of power does this need? How much power would this consume, and what voltages are we talking about?
That means we are working here in the normal 12 volt or 24 volt grids.
Okay, exactly for this.
Inside test stands, inside vehicles.
Okay, so that means essentially you connect all the cells with this. You have several of these, and then I see here, this would be your connection to the
Yeah, I must say I'm here. So there are two philosophies.
Yes.
So you can take the power for the CVM out of the stack.
Yes.
Or you can use an external power supply.
Okay.
So our approach is an external power supply, because we want to see the cell voltages directly when the system is switched on.
Okay.
So other solutions that use the stack power,
yes,
they can start measuring when the stack is on load.
Yeah. Okay, that's true. And I mean, I don't know the nitty-gritty of it, but I would assume that then they are also part of the load themselves, aren't they? You know, if you are that. Okay. So we've seen the different components, and so how does then the result of this look?
So the result within the CVM is we call it bar graphs.
Bar graphs, okay, all right.
So here I have some examples that may happen or that may not happen. So you have the normal operation. That means all bars have almost the same.
Okay,
so that means a little bit jittering.
Okay. So like if this were our cell setup again, you'd be measuring all of them, and then they're all running at a nice same voltage, right?
Exactly.
Okay, and everyone's happy.
Everybody's happy. Yeah, exactly. So in reality, it's a little bit different.
Okay.
At the borders of the stack, the voltages are a little bit lower than in the middle.
Why is that?
That's a good question.
Okay. Okay. All right.
That's a secret of our customers, but that is the consumption with the gases in the fuel cell. For example,
okay, yeah, the
is in the middle better than
okay.
the borders.
Understood. Okay, but because they have, or if they have cell voltage monitoring, they can see that. If they don't, they can't see that.
Exactly.
Yeah. Okay. So here you see you have, this is a normal operation. Okay.
So in this way, what we see here is an important security aspect of a CVM when you when you have lost in connection.
Yeah.
For example, one cable is
okay.
away.
Yeah.
Then you have a kind of cable break event, and
okay,
the CVM is demonstrating this. For example, here then the bars are missing.
Okay, so this would be if I pull this one out, you know, basically.
Exactly.
Okay, you have to. It's a little bit hard here, but okay, but obviously that's trying to prevent
we need to
make it
to fix it on the stack.
Yeah. Oh wow, I can see it's really it's almost hard for me to get this off here. But yeah, so that okay, so that would then this would go
exactly
down.
Then the bars disappear.
Yeah. Okay.
Yeah. As well, we can detect critical operation tasks within the fuel cell stack. What no fuel cell is like are negative cell voltages.
Okay.
So and this can be detected with a cell voltage monitoring device. So when you just measure the stack voltage, and one cell is negative, it's very, very difficult to see this one negative cell, and
it's impossible, isn't it?
Almost impossible.
Almost impossible.
And you don't know. Oh, what's this?
Yeah.
With the CVM, you can detect there is a cell with a negative voltage, and you can locate it very easily as well.
So essentially, each bar here represents one of these cells, essentially. So, and what we have here,
that's another display of the measurement data. So on the one hand, we have the bars and we have tables.
Yes.
And in the tables, we can give limit values.
Okay.
And if a measured value is above or below a limit, then it's marked red.
Okay, so that means okay. And so now we have talked about seeing this. I know you also have, I think you brought a little video how this is in action. Can we see that one maybe? That's probably going to help our users. Yeah. Okay. Yeah. So okay, this is running. So this is showing all the cells running at 0.5 volts more or less.
Exactly.
Right?
That's an example for a stack on full load.
Okay. Okay. So exactly. So it's going down that way. Okay. And I see a little bit of jitter here.
You see, yes, that's normal. That you see a little bit jittering in the cells, and you see the minimum voltage, the maximum voltage, the average voltage, and the stack total voltage in this field. That can be calculated by the CVM as well.
Okay, and I saw it. From time to time you see like this little one that jumps up. Is that normal when you're measuring as well?
It's normal, yes. That comes from EMC disturbances on the stack.
On the system, okay. And there we can see the table again with all the different values. Okay, so just before we get into the interpretation again, tell me a little bit about the pickup aspect, because I know we saw the one graph where we had, if I may, we had this thing that we had an interruption here. I know there are different techniques to actually touch or get to the cell to measure it.
So first of all, we must say that we consider the cell voltage monitoring device as kind of standard device.
Okay.
So the cell voltage pickup is a completely customer individual design. You have lots of different designs.
Yeah, brought different ones here.
This represents our. So we have some types of bipolar plate interfaces.
Yes.
So this is a kind of pinhole.
Yes.
We have pockets. That's a solution like this. It's not a hole. It's just a flat version.
They're lying in the pockets. Yeah. Okay.
And then the contacts are lying on the stack. And I have no example but the third group is a flag that comes out of the. So we can have a look at here. So you have pinhole geometry.
So pinhole is like this one.
Pinhole is like this.
This one, yeah. Okay.
Then we have pocket solution.
The pocket solution was this one that we saw here. So essentially, we see these. Okay, they are literally yeah, kind of lying in there, yeah? Or like lying between the cells. Okay.
And they must be pressed on the
Oh,
stack
they must be pressed,
to get the forces.
Okay, right.
That the contacts will remain
Okay.
in shock and vibration conditions.
So that's the pocket, okay. And then this is the flag, okay.
Yeah.
Where you kind of stick it on top. Okay.
Exactly.
And this is also a, what is this one? This is also pinhole. Oh.
This is also a pinhole geometry. We can take one out.
Yeah, I can see that. Okay, and that's kind of grabbing.
So
grabbing
such designs, we can have wired designs like here, and we can have flex card designs. Flex card when we do not have so many space, then we need flex cards. And here, this means the cell pitch is different to the measurement CVM pitch.
Okay, understood. So that means here we have essentially, let me say, the hardware aspect of it. That, you know, how do I contact the cell so that it does not, you know, that contact doesn't break, because I want a continuous measurement. Now, Marcus, I know you've been in this industry for a while. So why should one do this? Because, like I said, we had a huge fight, you know, because this costs extra. Yeah, I know if you are, let me say, a manufacturer of a cell voltage monitoring system, I guess I would know your position on if one needs this. But at least, like, why does it make sense? And I know that, for example, I think the Toyota the models, the first ones of they all had cell voltage monitoring, and then I know some other manufacturers brought out their vehicles without cell voltage monitoring. So can you tell us a little bit about the pros and cons of, you know, one having this and one not?
So first of all, I must agree you here. A cell voltage monitoring system costs extra money. That's true. But you get benefits from this system, because you can have a deep look inside the stack.
Yes.
And you see, we call it the state of health.
Yeah.
You see whether everything is fine with your stack or not. You see operation states that are critical.
Okay, but if sorry if I interrupt you there, but if I, you know, let's say a vehicle or a system has been running for, you know, 2,000 hours, you know, and there's a driver driving along the highway, and then there's a cell voltage monitoring running, and what does the driver benefit from that? You know, can he even, okay, if it tells like cell 27 of 100 that you have on the, but it's just losing voltage, what can the driver do?
The driver shouldn't see the cell voltage monitoring, just the control unit must see the data.
And then what happens? What do you do?
So for example, I can give you an example here. So for example, when you have a fuel cell car, and you let it outside in a winter night, it's cold, minus 20 degrees, and in the morning you leave your house. Then you start the car, and then the problem begins when you do not have a CVM, because when the whole system is frozen, it may happen that the hydrogen channels that the gas can reach the electrodes is blocked by a frozen water drop.
Right.
And then this cell is not supported with hydrogen. And when you start the engine and start driving, the fuel cell gets the power to the car. But when this cell has no hydrogen, the electrochemistry is looking for another reaction partner.
That's obviously detrimental to that particular cell.
And that are irreversible processes that destroy the cell.
Okay, so what would this cell voltage monitoring help in this case? Then we'll just
the cell voltage
not start the system or what?
No, the cell voltage monitoring system is detecting, stop, I have one or more negative cell voltages. So it's not allowed to get the fuel cell stack under load.
Okay.
And as in the battery, in the electric cars, there's heating elements around the stack. Then you switch on the heater, and you start driving with your battery.
Okay, and then you warm up the stack.
You warm up the stack.
Get it all right, and then go gently on it. Yeah. Okay, so essentially, you know, part of the wellness program of the stack, as we would call it, operations. Okay, yeah. Okay, yeah. Right. Okay, so I know that this is a good example, and but I see that there's been lots of development also with AI and all these kind of things and predictive this and that. I mean, because I've heard these arguments as well, would say, okay, I can learn, and then I don't need my cell voltage monitoring again. So can you give us a little bit of an outlook how you see the whole topic of cell voltage monitoring as well? You've been in it for a while, and I know that in the development space, surely it will be there, but just give us a general outlook from your side.
First of all, SMART is in this field since more than 30 years.
All right.
So, and let me just tell what our customers are telling us.
Yes.
Since more than 30 years.
So, yes.
Oh yes, at the beginning, research and development, we want to start to learn to know our stack.
Yeah.
Then we need a CVM.
Yeah.
Later on, we
don't need it. Exactly.
That's
the usual case.
But these customers, exactly, they are still using cell voltage monitoring systems.
Okay.
Yeah, but for the outlook, the CVM was a long time. It was just a research and development sensor.
Yeah.
It was nothing more. Therefore, we have modular designs with a flexible number of channels.
Yeah.
But we see in the last years that we get into small series applications. We have now projects that are dedicated to series applications, and that means new requirements on the system. But we see this progress here.
Okay, so probably also your costs coming down, the system's getting probably cheaper, yeah, and that's making it more attractive to have that in. And I guess from the engineer's perspective, you know, knowing what's going on in the system is always an advantage. And plus, I mean, this is used in fuel cell and hydrogen and electrolyzer systems, but also in battery systems and so on. This is also of relevance, I guess. Yeah, so I guess there's a big future for all of this. Thank you very much, Markus, for explaining us and taking us into this world of cell voltage monitoring. I hope you have enjoyed this and have learned as much as I have about monitoring and pickup and measurement and all these little things and jitter. If you liked it, then please give us a like, subscribe to the channel. And actually one thing, if you want to find more stuff like this or anything related to the hydrogen economy, go on highfinder.com. You can find the products of Smart Test Solutions there and also get in touch with people like Markus. And yeah, hopefully you can find great solutions for the hydrogen economy. Thank you very much for watching and enjoy another video on this channel. Have a lovely day. Thank you.
Thank you, Stephen.